Okay. Well, thank you for staying on for this. And I guess you might be wondering, what is Royal Mail doing here? We're not exactly a tech startup. We're not exactly 10 years old or 5 years old and thinking, how can we do cool stuff with neural networks? But I'm hoping to show you today that quite a lot of the things you've been listening to are extremely relevant to a more traditional industry, shall we say, and one that is looking to progress and go forward in this area. I'm Jeremy Bradley. I'm actually an academic by training. I'm a computer scientist, and I decided a few years ago to move into industry and to see whether we could make that final jump from technology and concept to actually delivery. And what I hope to show you today is two things. Firstly, some of the strategy that we're trying to run in the group from a fairly sort of high level, how we're trying to achieve some interesting transformations in, as you say, what is rather a traditional postal delivery industry. And also I just want to show you a little bit of sort of technical detail on a couple of the projects we've got running, and some of the challenges that then hits us when we try and interface that to a company which wasn't set up with a web page and a box saying, I feel lucky, or anything like that. Okay. Not that that's not a very good thing, by the way. Right. So, if the problem was to deliver a letter from here to Bristol, then that's not a hard problem. And even if the problem is to deliver a sack full of letters from here to Bristol, that's still not a hard problem. Even if it's 20 tons of letters, you know, eventually you hire enough vans or you hire a couple of articulated lorries and you do that. So that in itself is not a problem. So what I want to do is give you just a very, very sort of broad flavor of what the problem is. The problem is this. It's not 1 or 2 letters, it's 50 million letters every day, and it's going to 24 million addresses 6 days a week. So, you know, they actually do get Sunday off, it's nice. 115,000 post boxes, not to mention all the businesses we do direct collection from. And that goes to 1,250 delivery offices, which you may be familiar with if you've ever had to pick up a parcel that you weren't in for. Very sorry. And we have, I know you do get some interesting comments. All right, so, and you have little or no notice, or we do have little or no notice of those letters. You know, for a lot of those, they just go into the post box. And we have a commitment, it's a regulatory commitment to deliver first-class post to most of the UK within 24 hours, usually within 12. It can be posted at 5 o'clock in Penzance and arrive in Aberdeen at 8 a.m. the following morning, or with second class, 2 to 3 days. So, marvelous. Ooh, that's interesting. What are you doing? Come back. Good. So that's the problem. So it's essentially managing a very slow IP network, but ones where the packets, if you like, are rather large articulated lorries or vans, or indeed people carrying your post to your address. So it's complicated in the sense that it involves a lot of people. Nearly 200,000 people, in fact, manage the Royal Mail postal network. And they make decisions every day which impact in a good way, most of the time, sometimes maybe not such a good way, impact the operation and define whether we are successful or not successful in delivering what we need to deliver. And we like to think it's complicated, and certainly if you thought that if you think of the company as being the combination of 200,000 people's decisions in executing what the company does, and that was somehow the state that you would have to represent, then my goodness me, that would be a very, very complicated system. But being a computer scientist and someone anyway who abhors complexity, I like to try to make things as simple as possible, at least until I know that it's not as simple as I thought it was, and I ought to be putting a bit more time into working out slightly more interesting and maybe more complex a process. So let's start simple. And so the challenge we set ourselves, we're a data science group in the heart of this traditional company. We only started doing this about 18 months ago. We're essentially a sort of startup within a large company, and that's really the only way you can try and sort of couch yourself to succeed in such an environment, because otherwise it just overwhelms you. What we'd like to do is imagine that we could redesign the whole company. You know, let's start over. Let's see what could we do. How would we run this if we just started again tomorrow? So could we redesign the company around notions of data science, algorithms in AI, and decision science? And as a few of the speakers have alluded to today, you know, there are so many cool techniques out there, so many really exciting approaches that you could use. And oh my goodness, I mean, when I was lecturing computer science, it was true then, and it's just as true, if not more true today, you have to be so on the ball to know which of those techniques you should be selecting. Which from your toolbox should you be taking out of your bag to go, I'm going to try these three, and we're going to do a little race test with all of those, and then we'll see which ones go out. You can easily get lost in this particular forest, random or otherwise. So that's the challenge we set ourselves. And it sort of guides what we're trying to do. We have to do lots of miniature projects along the way to get ourselves there. But that's what we're about. Let's see if I can make this full screen again. No, it doesn't want to. Marvelous. Okay. So the first thing we need, rather happily after Maxime's excellent talk, is a really good forecast. And forecasts are the lifeblood, especially of an operational company, a company which depends rather a lot on the demand for its service. If people stop posting letters and parcels tomorrow, Royal Mail would just be sitting there drumming its fingers waiting for the next one. So, you know, we really do need a good forecast of economic activity, customer behavior, all of the businesses, quite a lot of tech businesses that feed into our network, in order to anticipate how we can move our resources around in order to service that demand and get letters there the next day. I said we have little or no notice. Yeah, we have, let me be a bit more specific. Yes, if you post a letter, we're not going to know about that. Not unless you've pre-bought some kind of tracked letter, but that's fairly unusual. If you're a business and you're talking to us and you're posting quite a lot of letters or parcels, then you might give us something called pre-advice. Pre-advice is where you say, I've got 5,000 packages, they're all about this weight, they're all about this size, and they're going to these 5,000 different locations, and you're going to get them in about 12 hours' time, and we'll deliver them directly into your warehouse, inject them into your network. So that's great, except it turns out they don't tell the truth all the time. And so they lie about the size and the weight and sometimes number and sometimes where they're going. I mean, how they expect them to actually get there, I have no idea, but anyway. So there's quite a lot of resources we need to move around, and we've obviously got this quite noisy data set that acts as a partial input into what we do. We've got the largest van fleet in Europe, which is has its upsides and downsides. 150,000 postmen and women, and who walk out in all weathers doing the most amazing on-the-spot optimization. Really very impressive. So let's be really simplistic about this. I said I wanted to start simple. Let's imagine a company, doesn't have to be the Royal Mail, but as a function. What does it do? What are its inputs? What are its outputs? And let's start from there, and let's then try to sort of scale it up and add a little bit of more color to that. So to start with, we're going to have a commercial forecast, a time series forecast, almost certainly. We're going to have customer data of the pre-advice I was telling you about. No matter how good or bad it is, it's still an input. We've got competitor information, lots of information about initiatives, marketing strategies, and marketing initiatives that our competitors are doing. Weather forecasts, big deal. If you're delivering stuff on a road network, which might not be fully open, or might be rather slick or something like that, and just general traffic information. We're working very closely with Highways England, who are themselves going through a transformative process of closing most of the motorways in the country overnight for the next 15 years. So a lot of inputs come in, and somehow we've got to transform that into outputs along the lines of resource configuration within the company. We want to actually deliver the stuff, so that's a pretty major output. And ideally, I say CO2, it could be anything, in terms of we want it to be as sustainable and environmentally unimpactful as possible, just so that we can keep on running the economy and helping the company sustain itself into the future. So let's just sort of flesh that out a little bit. It's not as simple as that. It's not as simple as this either, but so we'll start with the inputs in the top left-hand corner, and the forecasts and customer data come in. Then the company function itself is going to, the act of executing the company's function will in itself modify the forecast and modify how our customers talk to us. If we do a good job, our customers will change their behavior and maybe feed us more parcels and stuff. If we do a poor job, then they maybe give us less. So, it's not, our process will impact how other people behave. There is a game theoretic element to this, for sure. The resource configuration is much more of an internal transition. It's much more of an event which happens as a result, as a reaction to all of these inputs, and allows us to put our vans in the right places, our people in the right places, all of that sort of thing. And then the outputs we can think of as being a bit more than just delivering the parcels, though that is obviously really important. But also, we want to be able to predict the delivery windows of these packages with increasingly narrow windows of delivery. We want to provide tracking data to individuals, and again, we want to have as low an environmental impact as possible, and lots of other things I'm sure you could think of as well. But whatever you think about this sort of function, this sort of very, very hairy box that does all of these things, it's got to have certain properties that are really, really important to enable it to be useful and acceptable within a company environment. So first up, there are different windows of time at which you could execute this function to be useful. So a company would like to know not just how many vans should I have at this location tomorrow, or indeed today, when should I be sending these vans out? When should I be sending these people out onto to their delivery patterns? What route should they be taking? These are all the sort of key operational decisions that you want them to be able to inform and make decisions about right now. But you also want to know where's the parcel delivery market going in a year's time, 2 years' time, 5 years' time, 10 years' time, because I want to buy the resources or lease the resources that I'm going to make my deliveries in 5 and 10 years' time. I might want to have a plan for that now, or at least one to be able to put together in the next few years. So I've got to have a strategic view of this function. So I need to be able to run this function over very differing time windows, which means that my dependency on my forecast is going to be very different. I'm going to need a forecast which is capable of good short-term predictive capability. I'm going to need a forecast which is going to have a robust-ish long-term view of market conditions and demand conditions over a much longer time. And that's a very challenging thing to be able to do, but it's going to need to be done because that's exactly what the sort of company would expect to be able to do to make the decisions it needs to make. It needs to be able to cope with levels of uncertainty. All the things, almost anyway, that I've seen today and you've seen today, all of the amazing techniques you've seen, very few of them come up with it's definitely a cat, or it's definitely a dog. With 100% certainty, there is just that 1.2% certainty that it was a muffin, or whatever. Yeah. And therein lies the challenge. All of the things that you're going to put into this function, and most of the things you're going to get out of the function, are going to themselves have probabilistic behavior associated with them, or probabilistic weights associated with them. And you've got to be able to cope with that, either in the sense that you have to be able to consume something which has a distribution or has a probability associated with it, or when you produce your configuration, your resource configuration, the business, or maybe yourself, depending on who's making the decision on that data, has to be able to know what the thresholds are. If you're only 40% sure that you need an extra van at that location, well, do you put the van in that location or don't you? I mean, that's a deterministic thing, and you're only giving a 40% certainty to it. So what do you do? What's your threshold? What's the risk if you don't? What's the waste in cost if you do? And so on. So you've got to be able to cope with that. And yeah, as it says at the bottom, one of the things you'll do if you work in data science now, or if you go on to work in data science in the future, one of the best things you can do when you're running these algorithms, when you're running these approaches, is to be able to give the people who are consuming it an idea of the risk they are taking by acting or not acting on this analysis. And it's very easy to walk into a commercial environment where the process is all set up on I just want a yes or no, and your algorithm is saying 80-20, something like that. And to be able to have to explain, often the company is not configured to accept a probabilistic answer. It's configured to accept a yes-no answer. It's not configured to accept a probabilistic answer. So being able to show the company where the risk lies, where the probabilities lies, what the implications of those probabilities are. So, giving a mean is not often the best solution. Often you will find yourselves giving a conservative version of the truth. So, because you understand that if you err one way, if you give if you say it's a dog when it was a muffin or something, to put it crudely. So then you will incur some higher level of risk if you say that if you say that the articulated lorry should be in Warwick and not in Birmingham, then you incur a much higher level of risk in terms of the cost that delivers, or might cost the business, than if we just had two articulated lorries. Although that in turn has a cost associated with it. So you've got to take that into account, and you've got to be able to explain that to the people who are consuming what you're producing. Okay. Goodness, right, so I want to do this very quickly, and then I'll show a quick demo, and then we'll be done. Okay, so I just want to give you a flavor for what the Royal Mail network looks like. It's quite simple, and then, funnily enough, human beings are fantastic at making things very complicated. Right, so you post a letter in Southampton, and it goes into a post box. The postman comes round, or postman comes round in their van, empties the post box at about 3 o'clock, 4 o'clock in the afternoon, takes it to a delivery office, and that's what the DO stands for. There's nearly 1,300 of those around the country. Then a lorry will come to your local delivery office and several other delivery offices, pick up all of the post that's been collected from post boxes and businesses around the country, and take them to mail centres, which is what the MC stands for. So these are essentially just sort of big aggregating factories that take in the parcels, the letters that you post, and push them down the network. So at about the middle of this, there are things called regional distribution centres, which are nothing more than what are called cross-docking locations, where you take a big set of cages from all over the country, cages with bags of post in, and you say, these cages I'm going to put over there because they're going to Manchester, these cages I'm going to put over there because they're going to Edinburgh, and then you put those all onto lorries, and then off they go to the outbound mail centres, which are these red dots, which are about 40 mail centres around the country, and then they, in turn, push them out about 4 o'clock, 5 o'clock in the morning to their delivery offices for the deliveries to begin from about 6 a.m. through till 1 o'clock or so. So that's how it all works. And as I said, I'd like to start simple with something like this. This feels like a very nice feed-forward flow network to me. So let's just start with something like that. For the one or two people who are unlucky to have me lecture to them, at Imperial, I used to do things in queuing theory, so funnily enough, we deploy a queuing theory model to do this. And we put in anticipated post volumes into our DOs from forecasts that we run as a group, and we look at routing probabilities from DOs to mail centers to distribution centers to mail centers and back out again. And we apply very simple formulae in the sort of, if you've heard of Little's Law and that sort of thing, to look at what are the storage requirements going to be at these locations, which locations are going to be stressed in terms of going to receive more posts than they're used to, what's the implication then for how many people should be on shift, how many vans might they need, what are the size of the vans they might need to actually service that requirement on a daily basis. And yeah, it's a very interesting model. We've got some good collaborations with the CormSys, CDT and University of Southampton working on that now, and we hope to put something live going on that in the next few months. So along the way, as you're putting this sort of grand thing into place, you end up in a position where you're controlling your resource in some way, and that has certain complications and implications. So one of the resources we're asked to control is the van fleet, of which I said we have quite a large number of them. It's an enormous beast. It consumes 200 million litres of diesel a year, which is not a very happy fact, frankly, but there we go. It operates out of these depots, and the question we're asked is, in one of these projects, is how many should we have at our depot locations? Ideally, we'd like to have fewer. And the way the company has operated in the past is to sort of ring up the delivery operation, the depot manager, and say, you've got 100 vans, I'm taking away 5 of them. Make it happen. And that has problems, because what that does, they're used to running their operation with 100 vans. They might not be running it desperately efficiently, but they're used to doing it. And in fact, they've probably used up any slack that they may have had doing other useful, maybe look-ahead activities that they haven't told you about with their 100 vans. You then come along and say, I'm taking 10 vans away, and just saying, now do the same thing you were doing before. Everything else must stay the same, but those 10 vans are gone, you've only got 90 vans. And you give them no tools by which to help them solve what is an optimization and planning problem, and quite a hard one when you're dealing with 100 people that are also having to turn up and drive those vans at the same time. Then you introduce a lot of stress and a lot of unhappiness into the operation. And so one of the things we're really, really trying hard to do is to try and give parts of the business that are very stressed and rather unhappy because they have no tools, the tools to make them able to do the job they can do with the resources that the company is able to afford. Essentially making it the company's problem. If the company cannot solve the problem of how to deliver posts with 90 vans, then it shouldn't be trying to give it to someone who also is struggling to deliver the post with only 90 vans. And reasonably so, if the tool can't do it, then the manager is allowed to come back to us and say, well, why isn't your tool better? Why can't you sort us out? So we wrote them a tool. It doesn't look like this as far as the manager is concerned, but it looks like this behind the scenes. Let me just run it quickly. Okay, live demo is always fun. Let's see if this works. Oh, no, it doesn't. Yes, it does. Good. All right. Sorry. Oh, I do apologize. That's terribly flickery. Sorry. I do apologize if that's giving you a headache. I will try not to have it keep... Oh, dear, that's awful. It's giving me a headache as well. Okay, what you're looking at here, what you're trying not to look at here, possibly, is about 120 vans coming out of a location in Colchester. Each of these bars represents the duration of a van's trip out of its depot. And so the longer bars represent, maybe 10-hour shifts, and the shorter bars maybe represent 4 or 5 hour shifts, something like that. And they're each doing their own thing. They're leaving their depot, they're driving around their area, and then returning back to base. That's a bit more pleasant, I hope. No, it's not. But if I show you the right-hand side, you can get a feel for what's going on. So we've got at the top there, you can see on the right-hand side, you've got a van registration, you've got a route ID, and you've got a time of departure 5:09, the time it returns 5:34. Then the departure at 5:10, 5:11, 5:12, 5:13. Well, that's better. Yeah. Okay. And so on. So what's interesting about this, when we looked at this is just straight off the telemetry devices on the vans. What's interesting about this is, A, how very even the departure stagger is on the vans. So they really are trying to push out these vans as quickly as they possibly can. And then B, the variation in the size of those bars, the length of those duties, is enormous. So would it not be possible to look ahead to try and anticipate the length of some of these bars, some of these shifts, and to be able to say, well, actually, you can have a couple of shifts on one van and leave one van parked. And if we can show that you can do that consecutively for weeks, months, and so on, then I think it's reasonable to suggest you could probably do without one or two vans. However, here is the tool which suggests which shifts and duties you should be putting on the same van, not you work out what those duties should be yourself. So, and if this is as flickery, I won't keep it on the screen for long. Okay. So a bit of optimization later, and we can start to look at these durations. We can start to we can replicate the departure pattern from the DO. It turns out that the postal workers, the postmen and women, are running their own objective function when they're executing their daily duties, which is to basically get out of the depot as quickly as possible and return as quickly as possible and then go home. And that's what they do. That's their objective. And it's really important. Right, I'm going to stop that because that's horrible. You get the idea. It's really important to understand what other people are doing, because pretty much all the time, even if people don't know it, they're executing some kind of objective. whether it's teaching yourselves about data science because you're enjoying that, or whether it's getting the hell out of here because you're not. And I think it's important because one of the things, the next thing that happens after you ask people to change the way they behave is that they will either go, yes, that's great because that coincides beautifully with what I wanted to do, and it was quite an intelligent thing, and that's what I've been saying all along. Or alternatively, and possibly more often, they'll say, no, because that completely conflicts with what I wanted to do, and I've set up my life to depart at 10 minutes past 5 in the morning and be back at home by midday, and I go and collect my children and all kinds of stuff. So the challenge you have is to try to discover all of the constraints which are going to have the potential to impact on a system like this. And I think what I'm going to argue, just the last bit of the talk, is to say that a lot of what we do has a huge impact on individual people, and sometimes it's a more drastic impact than we might possibly realize, and it's just as important to take into account the constraints that those individuals have as first-class constraints in your system, because actually, if I'd run that optimization to its end state, we were saving 40 vans, not just 2. Well, if we save 35 vans and we're able to accommodate all of the key people constraints in that model, the company's not going to mind. They're delighted that they save 35 vans. And if we can make the people who work in the DOs happy because we didn't actually push it to 40, then it's actually going to be a system which takes, a system which works. Whereas if you pushed it to 40, it would probably stress the people working with it so much that they would just reject the whole thing and go back to what they were doing previously. Okay, I'm very nearly done. There's tons more to do. That big corporate function could just as easily be an AI-learned, machine-learned function. It doesn't have to be a piece of code, but we're interested as a group in all kinds of techniques and technologies, from optimization and game theory, stochastic robustness and scheduling, time series forecasts. All of these things are elements of your toolkit you will need and will be worth developing if you're coming into this, or if you're working in this field and you're used to that. We work with loads of companies. I run the academic liaison program for the group. We work with loads of universities as well. So Southampton and Lancaster and Imperial College. We work with all of these places, and I'm sure we'll work with many more, to get some of these approaches off the ground. One of the key ones we're about to embark on with King's College is a AI validation and verification exercise, which allows you to try to make robust claims about your AI module before you deploy it. As a data scientist, it's loads of fun to be able to play around with some of these fantastic tools and new tech ideas, but then you have to face the reality of installing them in an industrial system where the people are very keen on being able to test it, being able to reproduce it, being able for it to run within 0.8 of a second every time they press the button. And sometimes these techniques don't quite mold themselves to that approach. So being able to have a reasoning framework around some of these neural net or deep learning activities would be very, very interesting. So we're looking forward to doing more with that. So I'm just going to finish with the last couple of statements, which is this, which, there are some companies which are further down the route than this, and maybe we are, and I completely accept that. The companies are very used to asking individuals to work within the constraints imposed by that company because it's what they've always done. But I think increasingly, companies will have to optimize their operation, not just around their own customers' demand, but also around their employees' demands, because otherwise people will just stop working for them. And as I said, 200,000 people, there's quite a lot of people to accommodate, but I don't see we shouldn't be able to do that in the fullness of time. Good, thank you very much.